Now, the other one. Hypothesis test again. For one population mean again. But now, sigma is unknown. As we expected, we are going to take the t-score. We are going to use S, not sigma. It's the same as what we did in chapter 8. Use the S, use the T. Again, we are going to take p-value, the two-tailed, left one, right one, not from the Z, but from the T. But please look at the step number 1. Exactly same. Step number 2, determine the alpha, same. But step 3, the test statistic is not the Z, but T, but it's similar. Please look at the formula. It's quite similar. And definitely we are going to take a probability from the T table, not the Z table. But still, we are going to make the decision and interpretation. Do you have an idea? It's almost the same. It's almost the same. But we are not going to use the sigma. We are not going to assume we knew the sigma anymore. So we are going to use the sample standard deviation. That is only the difference. So let's try. Here's an example. It is the same thing. Step number 1, we can state the hypothesis exactly same way. Mu is equal to what? How do you think? Here is a mean, and here is a 6. Which one is the mu? How do you think? Probably one is a population mean, and the other one is the sample mean. Let me give a hint. Sample mean is from the sample. So who is the mu? Now, who is the population mean? What? 6, thank you. So the 6.6 is the sample mean from the sample. Sounds good, right? HA. Here is a mu, here is a 6. And we had 3 choices. It's not equal to, greater than, less than. Then which one? How do you think?
Greater than?
Why?
Because it says greater than, right?
Because it said it's greater than 6. Let me check. Actually the claim was here. Non-acidic. Do you know what is a pH? Anybody who major in biology? Or even not biology, but yeah, you know what is a pH, right? We want to test if they are non-acidic. When? Is a higher pH is a non-acidic, or lower pH is a non-acidic? It defined, see here? When is the non-acidic? Greater than 6. when pH is greater than 6, then we can say it is a non-acidic. Yes. So the alternative hypothesis is must be greater than 6. That means it's non-acidic. So is this a left one, right one? Right one, thank you. Second step, we need the alpha. Can you see the alpha?
5%.
Why? Oh, here it is. Thank you. 5%. Step 3, we need the t-score, not the z-score. But it's similar. The t is x bar minus mu 0 s over square root of n. Who was the x bar? 6 was mu. Then now 6.6 is the x bar, the sample mean, minus the mu 6. And here was the s, 0.672. Can you see how many sample?
15.
15 lakes. Give me the t-score.
$3.46.
3.06. 46. You got it? 3.46. Now we need a p-value from t. But t looks like the z, bell-shaped, symmetrical. 0. 3.46. And it was the right tail. So we need the right tail. So that is the p-value. We have to take the probability from the z table. I'm sorry, from the t table, right? So let me go to the t table. For the t table, we needed, the degree of freedom. What was the degree of freedom?
N-1.
Thank you, n-1. Just a second. Have you ever seen 1 minus n-1 before? Now, yesterday, I gave you the degree of freedom was n-1. But someday, we saw n-1. Can you remember the variance in chapter 3? What was that? We applied 5 steps to get the variance, 6 steps to get the standard deviation, which was sample mean, step number 1, take the difference. It's actually we took the distance from the center, square, sum, then what? Divided by n-1 for the sample variance, s squared. Now s is the symbol for the sample standard deviation. Then simply just take square, that was the variance. And I said the variance is on average. Do you remember? But I suggest to you just to take off 1. And I said I will explain to you later. Today is the later. Today is the day. y minus 1. Okay? Let me ask you. Give me any 5 numbers. Any 5. It doesn't matter. Any 5.
Like big numbers or small?
It doesn't matter.
I don't know.
Oh, come on. Give me 5.
7,
7,
2,
2,
10,
10,
12,
12,
18.
19. Thank you. Any 5. Give me 5 numbers. But you have to make average 5. You have to give me 5 numbers to make average 5. 5, 5, 5, 5, 5, 5. She gave me 5, 5, 5, 5, 5. Average will be 5. Yes, why not? Give me 5. And you have to make average 5 again.
5.
No. She gave me 5, 5, 5, 5, 5. But you have to give me
different.
different one.
I'll do 10,
10, 10,
0,
0, 0.
5.
Oh, 5, yeah. He gave me 10, 10, 0, 0, 5. You try to make sum 25, right? And divide by 5 will be 5. You want to try? 0, 0, 0, 0, and 25. Give me 5. 0, 0, 0, 0, 25. Oh, yeah, so good, so good. It's perfect. They made average 5. What was your 5s? I didn't ask you make average 5, but who was your 5 numbers?
I don't remember.
Why?
Those picked random numbers.
She couldn't remember her 5 because she just gave me any random numbers, right? But do you remember your 5 numbers? Well, yeah, why? What?
Because they were the same?
Yeah, 5, 5, 5, 5, and 5. Can you remember your 5? 10, 10, 0, 0, 5. And yours? 0, 0, 0, 0, 25. Just a second. When I ask her any 5, they are all free. So you couldn't remember. But when I ask you, you should make average 5. So she gave me 5, 5, 5, 5 randomly. But the last one must be 5. You gave me 10, 10, 0, 0 randomly. But the last one must be 5 because you have to make the average 5. Your case, 0, 0, 0, 0 randomly. It was not a random, but last one must be 25. Why? Again, he have to make average 5. How many numbers are free? Only 4. The last one, it quite depends on who were the first 4 numbers. Only 4 values are free. What is the name of n-1? The degree of freedom. Somebody asks you, you took statistics. Can you understand what is the degree of freedom? You can answer. What is the degree of freedom? The degree of freedom is the degree of freedom. Yes, it is. It is a very stupid definition, but it is. The n-1. Look at this. Look at this one. When we take the variance, in the very first step, we took what? Sample mean. Like as what I ask you to make the average 5. When we take the standard deviation, in the very first step, we took the sample mean. It is the fixed in the middle. And then we take the difference, take the distance, take the square, and take the average. So because of that, the degree of freedom, it must be -1. Does it make sense? So the degree of freedom is n minus 1. Just a second. Let me go back to the example because we need a p-value for this example. As how many sample size? The sample size was 15. Then how many degree of freedom? How many? 14, thank you. So let me put here, and let me take the t-table again. 14, where is a 14? 14 is here, okay? Yeah, let me make bigger. In the line of the 14, there are so many t-scores. Just a second, what do I need? What do we need? We need the p-value. Who was the p-value? The p. What is the p? Probability. Just a second. Where is the probability on the t-table? On the top. On the top, yeah, it's a very small font. Yeah, there is the probability. Yeah, please look at the t-table. The very first one is a 10%, it's a 0.10. And the second one is a 0.05, 0.025, 0.01, and the smallest one is a 0.005. From the z-table, we are going to take exact probability with the 4 decimal places. Unfortunately, from the t-table, we just take roughly the p-value. It's good, right? So anyway, how much was the test statistic? How much was the t-score? 3.46. You know, these are the t-scores in the middle of the t-table. We had another t-score, 3.46. Where is the t-score? Here is the 1.3, 1.7, 2.1. It's getting bigger. In this way, it's getting bigger. So I can expect our t-score, 3.46, is here. Does it make sense? Because the last one is the 2.977. You know, unfortunately, the t-table does not have all t-scores, right? Yeah, there is a 1.3, 1.7, it's 2.1, 2.6, and 2.9 only. But we had 3.46. But it is enough. Because the probability, what we need, probably is up there. Because our test statistic t-score is down here, so the probability must be up here. But who was the probability there? It was a 0.005, 0.01, 0.025, 0.05, and 10%. This way is getting bigger. The other way is getting smaller. So what I want to say is actually we need the p-value here. How do you think? Is p-value less than 0.005 or bigger than 0.005? You know, this one was 0.01. I'm sorry, 0.01. It was a 0.01, 0.005, and we can expect our p-value is here, to the right. So how do you think?
Less than.
Thank you, less than. In the t-test, from the t-table, we can't get exact p-value. But roughly I can say the p-value is less than 0.005. It will be the p-value. It will be the range of the p-value. So let me take this one. Now I can say the p-value will be less than 0.005. I'm sorry. I don't know how much it will be exactly. But roughly I can say the p-value will be less than 0.005. How much was the alpha? Alpha was 5%. Okay, now, how do you think? Is p-value less than 5% or bigger than 5%? You know, it is 0.5%. We got p-value less than 0.5%. Is it less than 5%? Yes, it is less than 5%. Then what will be the decision? Reject the null. Who is my girlfriend? I rejected Miss Null. Then who is my girlfriend?
Alternate.
Miss Alternative, yes, thank you.
Why did you go off of that line on the T table, off of 14?
Yeah, I don't understand that.
Why didn't you go off?
14 was the degree of freedom.
Oh, okay.
Who was n minus 1. N was 15. Minus 1, 14. You know, when we take the probability from the z table, we didn't need the degree of freedom. You know, the degree of freedom is only for the t table, the t distribution, because we use S. S had the degree of freedom, n minus 1. You know, the standard deviation was from the variance. In the variance, there was n minus 1 in the degree of freedom, in the numerator. So the t distribution needs the degree of freedom, n minus 1. So you have to go to the line and compare to the test statistic we took for the test statistic. And we guess, we expect, where is the p-value? Unfortunately, we just take the range of the p-value. But it is enough to make a decision. Reject the null. Reject the null. And now, finally, we have to make the conclusion, interpretation, based on the chosen alternative hypothesis. What it said? Greater than 6. Just a second. What was greater than 6? pH. pH is greater than 6. Is it acidic or non-acidic? Non-acidic, yes. So how can you make the conclusion? Let me cheat. I can say the conclusion will be the high mountain lakes are non-acidic because we made the decision, alternative hypothesis is true, greater than 6. pH is greater than 6, non-acidic. So you can interpret the lakes are non-acidic. It's good?